place that we use logarithmic differentiation is when we have a lot of a function that are as product of a bunch of functions. The example that we're giving in part 1 of example 2 is not too many products, but still it actually it pays off to learn it with fewer products and see how it works with more products with the same rule of it. So if I follow the same basic process that I did with the logarithmic differentiation when I had a non-constant to a power non-constant, and here the first step that I want to take is to basically take the natural log of both sides. So I'm going to get natural log of y is equal to a natural log of 2x plus 1 to power 5. Oh, too many. Let's change this, and then x to the power 3 minus 1 to power 3. Now, when I'm taking the natural log, and the next step is always simplify this, and so natural log of y. This is a product, so I know the product becomes a sum, and exponents for each piece comes down. So I can write it that way. I can write 5 natural log of 2x plus 1 plus 3 natural log of x to the power 3 minus 1. It's important to notice that I cannot simplify this any further using the product rule because there's no product or exponential inside, as exponential should be covering the entire thing. See, over here I did a power law first. That was natural log of it was natural log of 2x plus 1 to power 5 plus natural log of x to the 3 minus 1 to power 3, and then I did an exponential law and it worked like that. And so now, so the first step is done, and it looks a lot simpler than we started. So what logarithm does, it's one of the properties of logarithm that is used a lot in math, is it takes the product and makes it into sums. And then taking derivative of both sides of this is gonna, again, on this side it gives me y prime divided by y. Here it's 5, which is the coefficient, and then derivative of natural log, it's going to be 1 over the inside times the derivative of inside. Oh, sorry, just x. And then plus 3 times, because 3 is the coefficient, 1 over derivative of 1 over inside times the derivative of inside again. And so we've done this, and then I have to solve for y prime, and solving for y prime will result in y times this entire thing. 2 times 5, 10 over 2x plus 1, plus we have a 3 over here times 3, 9x to the power 2 over x to the third minus 1. And then if I replace, if I want to replace y with what it was to begin with, let's get rid of the y over here and replace it with what it was, the function that it was. And I get the answer So that's the function. And that's how we solve a derivative of product using the logarithmic differentiation.